I'm Ian Sanderson, the president of Antiage.
I'm Dr. Rob Knight, lead scientist at Antiage.
And today we're going to give you a short tour of our exosome lab. So this is our GMP production lab, and this is where Rob does all of his magic. So Rob, tell us a little bit about what goes on in the production lab.
So this is where we do all of our cell manufacturing. So we grow the cells, we collect the conditioned media, and we do our first stages of our exosome purification. So inside the room is a class 7 clean room. So it's got high pressure on the inside of the room, and it kind of forces all the air outwards and out this way. So we keep the inside nice and clean, and we push any sort of dust and dirt particles out. So let's go in and get changed so we can enter the clean room. To enter the clean room on the inside, we have to put on boiler suits. So we've got to kind of cover our hair, glasses, suits, just to make sure that we've got no sort of contaminating particles from outside entering our products inside the clean room. So this is where we do all of our cell culture, cell manufacturing, and then our exosome purification. We start off growing the cells, we collect the conditioned media, we concentrate it with tangential flow filtration, and then we purify our exosomes using size exclusion chromatography. So let's take a look through the process. We grow our cells in incubators, so we grow a combination of human bone marrow MSCs and human umbilical cord MSCs. So these are sourced from the US, so they're US donors. So what we do is we start off culturing our cells in 2D flasks, and then these kind of move up in scale, so we're culturing in quite large multi-layer flasks. And then finally we kind of grow up into these bioreactors. The bioreactors allow us to grow a huge number of cells in quite a small volume of media, which allows us to have a really concentrated exosome product at the end. Once we've finished our culture in the bioreactors, we collect all our conditioned media. Typically we'll process about 10 litres at once. So we take our 10 litres of conditioned media and then concentrate it using tangential flow filtration, which is over here. This is our TFF system, so tangential flow filtration. So this allows us to have a really concentrated exosome conditioned media product over here, which we can then move on to the next stage, which is size exclusion chromatography.
Now this is something that's actually fairly uncommon, or maybe it's just a high level of production to actually use two different methods, right? So tell us about dual method. Why are we choosing to both do tangential flow filtration and size exclusion?
Yeah, so many people would just use one method. There's also different methods that people can use to isolate their exosomes, but it's been shown in the literature that having a combination of methods is a really good thing, but also having the combination of TFF and size exclusion gives you a really pure final product of exosomes, much fewer contaminating proteins, and it's all GMP compliant. So this is our kind of small scale size exclusion chromatography. So what we can do is load our 100 times concentrated conditioned media to the top of the column, and then bigger particles get separated from the smaller particles.
So just to restate that, basically we're doing the tangential flow filtration, which ultra concentrates our exosome media, and then that ultra concentrated media goes into the size exclusion so that we isolate just exactly the particles that we want.
Yeah, exactly. So our actual final product never leaves the clean room during production. So we take the 1 aliquot to determine particle concentration, and then we kind of move into vial filling once we've diluted our product. And then once we've done the vial filling and vial capping, we can then move to the lyophilizer, where we will lyophilize our exosome product. So the lyophilizer, or commonly known as a freeze dryer, removes any kind of water from our product. So what we can have is we can have an exosome solution that goes in, and then with really controlled drying temperatures, we can remove all the excess water, which leaves us with a final product.
So here we are in our analytics and research lab, and I'm going to have Dr. Rob show you some of his toys in here and the tools that he uses to characterize and help manufacture our exosomes.
Yes, this is our analytics lab. So this is where we do all of our exosome characterization and our functional testing of the exosomes, as well as start doing some more research and development for potential new products as well. We culture a whole range of different cells in here. We've got human dermal fibroblasts, human keratinocytes, immune cells, so we look at the anti-inflammatory functions of our exosomes. So all of those things are sort of characterized and tested in here. The first sort of piece of equipment we've got here is this multi-mode plate reader. So this is kind of a real workhorse in the lab here. We do lots of things with it, so we can measure cell proliferation assays, a lot of ELISAs as well, so we're measuring absorbance for different things. And then moving sort of down, one of the more relevant sort of pieces of equipment we've got for exosome work is this sort of nanoparticle tracking analysis. What we can do here is we can measure the sort of particle size and particle concentration of our exosomes. So exosomes are typically sort of like 100 nanometer sized particles, so we can't really see them down a microscope. But what happens here is we can inject our exosome sample, fires a laser through the sample, and then based on how the laser interacts with the particle is kind of the image we kind of see on the screen here. Really allows us to make sure we're getting the right number of particles in each vial.
So Rob, tell us a little bit about this new machine that you've gotten in. What is this for?
Yes, this is our new rotary evaporator that we're going to start looking at doing some new sort of technologies with. So what we can do here is we can customize our sort of lipid nanoparticles using different combinations of lipids, and then we can incorporate different things into these lipid nanoparticles. So basically what we're doing here is sort of making synthetic exosomes.
How close do you think you are to being ready to test these synthetic exosomes?
We're very close actually, so we've already started making these liposomes and incorporating growth factors. So we're getting some initial data on sort of encapsulation efficiency with different growth factors in these lipid nanoparticles. So I think it's a technology which is soon to be ready, coming soon.
So Rob, you have your PhD in exosomes and you've built out this lab. You've been in lots of other labs around the world. How many labs do you think there are in the world that can do this kind of exosome research and production?
This is definitely one of the top labs in the world. We've got a GMP clean room, we've got all the latest exosome technology. We're definitely up there in the top labs in the world for the capacity and the capability that we can do with our exosome work here.
Very cool. Well, we're very proud of you and the work you do here, and thank you so much for showing us the lab.
Thank you.